Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. First of all, thank you and welcome to my project presentation titled STM32 Training Kit for Beginner, a STEM educational tool with integrated sensors, peripherals and IoT capability. So my name is Ahmad Salman bin Muhammad Burhanuddin. My project code is EA2514. My supervisor is Encik Ahmad Swadi bin Muhammad Zahari. Alright, moving on to what I want to discuss today. So this is my content. The first one will be background study and problem statements. The next one is literature review, and then project aims and objectives, scopes of project, approach and methodology, planning and chart, preliminary project outcomes, conclusions, and lastly reference. Alright, let's start with background study. Alright, current training kits that existed. So globally, the big three beginner kits are like Arduino for simple 8-bit tasks, Raspberry Pi Pico for Linux style scripting, and ESP32 training kits for entry-level IoT. They are affordable and friendly, but non-teach industrial grade ARM Cortex-M workflow. This is actually essential for in many embedded and IoT industries. Okay, so what is STM32 Training Kit? An STM32 Training Kit is an educational platform designed to introduce students and beginners to the world of embedded system and microcontroller programming. So the kit focuses on helping users understand the key concepts like GPIO control, ADC reading, UI communication, and basic IoT connectivity. Okay, what is STEM education? STEM education integrates science, technology, engineering, and mathematics into a cohesive learning model based on real-world application. And embedded training kits like STM32 introduce students directly to technological innovation through microcontroller-based project. Alright, let's move on to problem statement. Alright, so for the first problem statement, limited access to practical STM32 based microcontroller learning. So STM32 microcontroller are widely used in industry, but beginner friendly and affordable learning kits are hard to find. Existing kits are often too complex or not modular, making them unsuitable for self-learning or classroom use. So second problem statement is lack of beginner kits introducing ARM Cortex-M architecture. So most popular educational kits such as Arduino, Raspberry Pi or ESP32 focus on 8-bit systems or general purpose computing. They rarely expose students to ARM Cortex-M microcontrollers like STM32, which are essential in many embedded and IoT industries. Okay, so for the last problem statement is limited exposure to industry standard development tools. So current beginner kits rely heavily on hobbyist-friendly platforms like Arduino IDE or simple visual interface, which students miss opportunities to work with professional tools such as STM32 Cube IDE, STM32 HAL, libraries, and advanced debugging environments which are widely used in the embedded system industry. Alright, so moving on to literature review. Okay, so this is the comparison between Arduino Training Kit by IZ and Raspberry Pi Training Kit by Intelitech Edu Solution. So Arduino Training Kit by IZ use architecture of 8-bit FVR and target user is beginner. Included components on the training kit is the HT11 with IR sensor, LDR, LCD I2C, breadboard, pre-soldered modules, and IoT capability not built-in, requires external modules like Wi-Fi module. Software tool used is Arduino IDE, and industry alignment is for educational hobbies or hobbies use. For Raspberry Pi Training Kit, the architecture is use ARM Cortex-A, which is general purpose Linux based computer, and target users is beginners to immediate. Included components as varies, include GPIO, camera module, sensors, IoT capability, not native, require extra setup with MQTT or not read over Linux. Software tools used is Raspberry Pi operating system, Linux, Python or and Scratch. Industrial alignment, general computing and prototyping. Alright, this is the solution for the problem statement that I've already stated. So the first one is design a modular STM32 training kit with pre-arranged pin headers for sensors, output and communication modules. Provide students with direct hands-on experience working with STM32 ARM Cortex-M microcontroller so that it's allow them to understand and apply real-world embedded system concepts. And the last one is incorporate the use of STM32 Cube IDE, STM32 HAL libraries and debugging tools into the learning module, helping students build familiarity with the same industry standard software and workflows used by professional embedded system engineers. Alright, so the next one is project aims and objectives. Alright, my project aim is to develop a beginner-friendly STM32 training kit for hands-on STEM learning. So my project objectives to design an STM32 training kit as an educational tool, to test the STM32 training kit's functionality, and to create a user handbook or learning module introducing basic STM32 microcontroller concepts. Okay, moving on to scopes of project. Alright, so for the scope of project. So this project will produce a beginner-friendly STM32 training kit based on the Nucleo L0538 board, this one, which is the STM32 microcontroller board. Okay, so the next one is the system is modular with pin headers to facilitate easy components connection. These pin headers, if you can see it. Okay, so the last one is the development. Development covers schematic design, PCB design, firmware development, and user manual preparation. Okay, the next one is approach and methodology. Okay, so this is my block diagram. For power supply, I use micro USB to USB A cable, this one. And then for process, I use STM32 Nucleo L053R8 as a main microcontroller board. And then for input block, I use LDR, LM35 ultrasonic sensor that fits the STM32 microcontroller. For output block, I use RGB LED, 7 segment, buzzer, LCD. So if Wi-Fi enabled, data is pushed through ESP01, which is Wi-Fi module, to a local dashboard. So this is the component used: STM32 L05TR8 as a main microcontroller board, ESP01 as a Wi-Fi module that can be transfer data, senses data to the IoT platform or a local dashboard, and then active buzzer, 7 segment, ultrasonic sensor, RGB LED, breadboard. So next one is push button, LCD I2C, LDR, light dependent resistor, LM35, 3 LED, green, red, and yellow, which is 10mm, and pin headers, and last one is jumper wire, male to male. Okay, for software use, I use Arduino IDE to set Wi-Fi credentials for ESP01 Wi-Fi module, so that I can send the data from the ESP01 to the IoT platform or some local dashboard. And then STM32 Cube IDE to program the STM32 microcontroller board, and Eagle software for PCB design for me to design the STM32 training kit. Okay, so this is my flowchart. First start and then initialize peripherals, input, outputs, Wi-Fi, and then read inputs. Either you want to read push button, LDR, LM35, or ultrasonic sensor, and then process the input data on the STM32. And then if you want to use ESP01 to send the data on the IoT, then if it's true, then send data to IoT platform like Blink or maybe a local IP address. And then you can display the output on the LED or buzzer or LCD or 7 segment. You can even display the output without using the ESP01. Moving on to planning and Gantt chart. Okay, so this is the Gantt chart that I've created. There's plan and actual. So the task that I did is project briefing session, searching project title, find objective and aim, study sensors and STM32 documentation, survey proper components, decide project title, explanation about logbook, preliminary report, submit A1, A2 and A3 form, sketch block diagram and flowchart, prepare Gantt chart. So next one is buy components, code and test LED and push button, code and test 7 segment display, submit logbook week 5 to week 7, code and test LDR sensor, configure ESP01 Wi-Fi web server, update logbook week 8 to week 11, code and test ultrasonic sensor, code and test RGB LED, update logbook week 12 to week 14. And then code and test LCD I2C display, submit methodology paper, code and test LM35 temperature sensor, design PCB schematic and board layout Eagle, update logbook week 15 to week 17, and then create slide and video presentation, seminar final year project proposal, and final report. Alright, moving on to preliminary project outcomes. Okay, so for circuit testing, I code and test LM35 LED ultrasonic sensor. I also code and test RGB LED, LDR, and also ESP01 for IoT test, and also 7 segment. Okay, for coding and STM32 configuration, I configure to test the LDR, temperature sensor, LM35, and also RGB. This one is for LCD I2C configuration and also coding. Okay, so this is the result of the RGB LED emitting colors like cyan, purple, and white, and LDR value is transferred from the ESP01 to the local IP address, and then the LCD I2C display hello world, and then the LDR value is displayed on the serial monitor STM32 Teraterm. Okay, so this is the result of testing LM35 temperature sensor and also ultrasonic sensor. This one is the schematic diagram that I've designed for my STM32 PCB design. Okay, so this is the PCB footprint that I've done for now. It's not complete yet, but I will complete in the future work. Alright, now conclusion. So in conclusion, the project is making good progress toward its goal, and all main components have been tested and work well with the STM32 Nucleo L053R8 board. The PCB schematic design is almost finished with final layout plan soon. This progress almost matched the first project objective, which is designing the STM32 kit and testing components. And in the future, the next step will be complete PCB design, assemble the hardware, develop integrated application combining sensors, output and IoT, and lastly create a user manual and learning guide. Alright, lastly, reference. This is all of the reference that I've used. That's all from me. Thank you very much.